Hello, I'm Ryan Ausanka-Crues. I'm an engineering manager at Google, and I'm here today to talk to you about some of the work we're doing to help make it easier for developers to create better multi-device experiences. So when I say multi-device experience, I'm defining it as experiences that involve at least more than one device. We generally classify these into two types of experiences. There are personal experiences. Those are the experiences you have with your own devices, something like starting a purchase on one device and completing it on another device. And then there's also communal devices, which we define as the experiences that involve other people around you. Examples of that would be like a digital board game, where you have a board game with a digital component, and how do people participate in that on their own devices. So one way we're helping developers build better multi-device experiences is with our cross-device SDK. Our cross-device SDK is a new layer that sits above the existing nearby layer, as well as our underlying radio technologies. As you may remember, we announced this SDK back at Google I/O way back in May, and I'm happy to announce that we were able to publicly launch it last Thursday. Right now it's a developer preview. And we always say, well, what do you mean by a developer preview? How is that different than the way Google's used beta for interminable periods of time in the past? The reason why we describe this stage as a developer preview is that it's intentionally an early release to allow developers to give us early feedback to help shape the way that the SDK evolves. But being a developer preview in an early release means that while we're trying our best to avoid it, it may actually involve breaking changes based on the feedback we receive. We'd hate for someone to miss the subtlety of it being a developer preview, put an app into production, have end users then have a broken experience when a new version of Play Services gets released. So what we're doing is we're restricting the access to the Play Service module that our SDK depends on to only be available for the Play Services beta program. So you have to opt a device into the Play Services beta program in order to be able to use the SDK. And so what that does is it restricts people from deploying an app to production because it just won't work because the SDK is not available, or the Play Store module is not available. Once we're confident that we've gotten it to a place where we will not have breaking changes, that's when we'll actually further release it out and remove that restriction and have it be available in production. The version we released last week is a minimally viable developer preview and is only the start of the plans we have for the SDK. The initial version only supports experiences between phones and tablets. So you can have two phones talking to each other, two tablets, a phone and a tablet. It includes the session transfer and sharing APIs we announced at I/O, as well as the underlying discovery and connections APIs. However, the wake up API we mentioned at I/O, we actually folded into the discovery API. So that's an example of like a breaking change that we made internally between the time we announced it at I/O in May and we released it now. So it provides sort of a window into some of our thinking there. Restricting to Play Services beta also means that we can deliver updates more quickly. It's a weekly cadence in which Play Service updates go out to the beta channel. And the SDK is available open source. It's on GitHub right now. We also provided a couple of sample apps, one in Kotlin, one in Java, that are also on GitHub. So what's available today encapsulates and abstracts the device discovery capabilities that were initially part of the Nearby Share product experience. And then we use the authorization that occurs from that Nearby Share logic to then bridge it to a nearby connection. So as an application developer, you don't have to worry about any of the authorization or discovery logic. You don't have to request any special permissions. That's all encapsulated inside of our Play Services module. Additionally, the cross-device SDK provides a higher level API that I mentioned a little bit, which is the Sessions API. And we really, really highly recommend that you use that API rather than directly using the connections and discovery API. It's way more convenient. If there are use cases where you say, hey, you know what, Sessions doesn't quite work for us, we'd love to hear about that. But from all the conversations we've had with developers internally, the Sessions API is where all of them are developing against. So here's an example of how a session transfer works. And I mentioned this back at I/O. It's changed slightly, but not much. And the way it works is on an originating device, which is where you're starting the experience. you can initiate a transfer. And so you call transfer session. That then causes the device discovery UX, that's a system UX, to appear. The user can then select the device they want to transfer that experience to. And then there's, that moves over to the other device. And then it cleans up the experience on the originating device. So once the user selects the receiving device, it's just transferred over to the new device. For an experience in which the developer wants to share the experience rather than transfer it, you also create a session, and then after creating the session, you call share session instead of transfer session, which similarly launches the discovery UX, and then after a user selects it, then a second session is created on the receiving device that allows it to then participate. And then that session can be used to transmit data back and forth between the devices. The application running on the receiving device is given a secondary session, as I mentioned, and that secondary session is bidirectional. So you can send from the receiving device to the originating device and vice versa. Right now it's limited to just 2 devices, but as we expand in the coming months, it'll allow more than 2 devices to participate, and similarly you can share across the session across all of the devices. So this is to put some better visuals on what I just mentioned. And so on the left-hand side, you can see this is a fake food delivery app that someone on our UX team created just as a conceptual representation of this work. There's a invite to order button at the bottom. If the user taps on that button, then the code actually then calls the share session API, which then causes this UX to appear, which is the second screen, which shows all of the devices nearby that the user is authorized to see. If the user chooses one of those, then a system dialog notification appears on the target device that asks them if they want to participate in the session. Within there, you'll see there's a little, it's hard to see probably, there's a little gray box that has an app icon as well as some text. That text is custom text that the developer can add that will appear there to give some context to what app is requesting the session, as well as what is that session going to do. And so in this case it says, join my group order at Savory Superfoods. So in order to reduce a user's cognitive load about device discovery and their visibility settings, we are reusing the existing setting that exists for nearby share. Not only are we reusing the setting, we're also reusing the actual UX for enabling the setting, as well as for the temporary public visibility that you get if someone's trying to share nearby. So as much as possible, we're trying to create mental models in the user mind about how they interact with the devices around them. So I mentioned what we have so far. Coming soon, we're working on bringing to the other Android form factors beyond phones and tablets. So that's TV, that's auto, that's Wear. We're also working on, as I said, allowing more than 2 devices to participate in a shared session. And we're also working on allowing the initiation of a session transfer from a receiving device rather than only from the originating device. So beyond the near-term goals we have that I mentioned on the last slide, we're working really hard on migrating the Play Services component into Android open source project. And we are also planning on bringing the cross-device SDK to additional platforms beyond Android, because we know you don't just build for Android, your companies don't just build for Android, and your users don't only have Android devices. So to be able to maximize the value that both developers and users get from this, it needs to be as broadly available as possible. So I can't talk about the future without once again mentioning that the whole reason that we're launching this early is to get feedback from you. And so we want developers to help give us the feedback on what our roadmap should be. And we really value that, and we're going to be very active in soliciting that feedback and responding to that. So please, any feedback, unfiltered, as frequent as you want, just give it to us, and we would love to have that. So that was all about the cross-device SDK. I'm not here just to talk about that SDK that we launched. I mean, you can go watch the I/O talk if you wanted to just learn about that. I also want to introduce you to the broader efforts that we have to support multi-device development. So at Google I/O, we introduced our mission that drives our efforts to support multi-device development. And to do that well, we really must deeply empathize with the challenges that developers face when they're trying to build multi-device experiences. But developers aren't a homogeneous group. Google supports many different types of developers. And each one of those has overlapping needs, but they also have unique needs. And our multi-device platform effort is the unification of the different technologies that we have to support multi-device development and multi-device developers. So what that means foundationally is there's the cross-device SDK I mentioned, there's the nearby stack I also mentioned, but there's also the companion device manager. And that's already in AOSP, and so one of the things that we're really focused on is not making sort of localized decisions on individual technologies, but making sure that we're thinking at a larger, higher perspective to make sure we're having coherence and consistency across the APIs we're providing to developers, as well as better guidance on what APIs should be used and when they should be used. So beyond just here's some APIs to go build your experience, we know that one of the big challenges developers face is ensuring their experience works across the supported devices. It's very challenging. It's something we struggle with at Google, in fact. So to help with this, we're introducing a new concept that we call network simulation. And so it's allowing the simulation of experiences involving multiple devices. Right now, to even manually test a multi-device experience, you need to use physical devices. And while we'd all love our employers to go buy us the latest Polestar 2 car so we can test out our Android Auto experience with our Android phone, even at Google, we can't do that. And that's sort of just like a basic part. I mean, as any of you who've ever managed a test lab before Firebase test lab took over, it's really fragile having real devices that you're having to maintain for automated tests. They're slow. It's very hard to parallelize tests across a suite of devices. It takes up a lot of space. And even if you have those devices, how do you simulate the ranging of devices? How do you simulate devices getting further apart or closer together? All of those things are challenges, not just with physical devices. They're challenging with emulators and AVDs as well. And so while AVDs are an essential part of the developer's workflow, and they're a great way to parallelize unit tests and other automated tests, they exist in their own isolated sandboxes, and they don't have any way to do peer-to-peer communication. Well, that's not exactly true. You can get AVDs to talk over a simulated LAN connection. It's super simple. This is all you have to do. Which, if you've ever tried to do this, yeah, it's possible, but it's not something you can ask every developer to do or you can easily set up as part of a new test run. We really need to make this simpler. And not only do we need to make it simpler for the LAN experience, we need to make it work across all radios. It's not just about Wi-Fi. It's not just about BLE. It's also Bluetooth Classic. It's also UWB, even NFC. All of the different radios that you use to be able to interact between devices need to be simulated so that you can actually simulate real-world experiences. So to address this, we've built a new technology we call NetSim. And the goal of the project is to provide an integrated way to simulate radio interactions across all radios and a convenient client API to simulate both ranging as well as packet loss and other network conditions. In fact, any enterprising Android enthusiasts have probably seen that we recently introduced a new directory inside of Android open source, tools NetSim. And that's actually the foundation of this new effort. And it builds upon some of the excellent work that the Google Android, the Cloud Android team at Google has done and is doing to support being able to concurrently launch multiple AVDs, as well as to be able to simulate the connection of devices across virtual radios once you've launched them. So one of the things that I mentioned on the last slide was that there was a little box that said Mobley. And this is the way at Google we write multi-device tests. It's an open source project. We launched it in 2017. So it's been out there for 5 years. If you look at the GitHub, it's steady progress for 5 years because it's under active development at Google. It's used by millions of tests a month at Google. And we designed Mobley about automating not just sort of simple multi-device tests, but complex ones. Things like having to reboot a device during a test. That's handled by Mobley as a framework. It also supports not just Android, but it supports Chrome OS and iOS. And it's expanding to additional platforms because it's so important at Google that Google engineers don't just build for Android also. And so there's additional platforms that are on their way. An example of that is it's officially integrated with the Matter project through work with the Connectivity Standards Alliance. And so because of all of this, because of how foundational it is to Google, and because of the active work it's doing to support these really complex test cases, we are using that as a foundation for the NetSim testing. And so here's an example of using NetSim to execute an automated nearby share test. And you can see on the left-hand side, the phone is initiating a share request. It is then going to discover the device on the right. And this is all simulated. And you can see then the right-hand side gets the notification to approve the sharing, and then the article transfers over. And so this is just between two AVDs that are running side by side. And this is done with the combination of the cloud Android work as well as NetSim. And so that's using a simulated BLE connection. The AVDs themselves think they're talking BLE, but actually there's a simulation layer underneath that's actually doing the connection. So here's a sneak peek of how the integration is going to work in a Mobley test. In your test, you can directly manipulate the network, and you can also have the ability to have a single call to affect all the virtual radios. So rather than having to separately change the ranging information for UWB, from BLE, from Wi-Fi RTT, it's one call to change the range information, and we update the radio readings for all of the different radios. So the roadmap for NetSim includes expanding the virtual device control and network capabilities, as well as an integration with Android Studio. So for us, we know that external developers all depend on Android Studio. And it's not enough to just say, hey, here's a way that you can run these tests via CI. You need to be able to actually easily launch and run the tests from an Android emulator. And you need to be able to actually do this from a manual perspective as well. Automated tests are great, but so many developers rely on AVDs as part of their workflow, especially when you think about non-phone form factors and the ability to launch specific form factors, specific form factor AVDs from Android Studio. So, final reminder that the cross-device SDK is available now on GitHub. There's some other links in here that I provided that are just extra information to different aspects of the cross-device documentation. For the multi-device platform, there's the nearby documentation, the CDM documentation, and once again, the cross-device SDK. And then for our multi-device simulation, here are some specific links. You can monitor the work happening in AOSP if you would like. You can check out all of the great work that's been done in the open source on Mobley for the last 5 years. And then we also have more information about the work that Cloud Android is doing to support concurrent execution and simulated connectivity. If any of you have any questions or you want any of these links, go ahead and ping me. There you can see my Twitter handle there. My email address is easy as well. It's my Twitter handle at google.com. And we're very excited to work with all of you to help make building multi-device experiences a better world. Thank you.